Hello, today we're going to talk about one of the 23 famous design patterns, which is a state pattern. So, first of all, we know from the book of Gang of Four, we have like those 23 design patterns, and then they will be divided into three different categories. Would it be structural, behavioral, or creational? Specifically, the state design pattern is a behavioral design pattern. Imagine you have an object, and this object has different states, but based on each of these states, a different behavior should be shown. Well, that's when the state pattern comes into play. In other words, a change in internal state will result in a change in behavior. And of course, with the consideration of the fact that anything can happen in an object's life cycle. Now you might ask me, okay, how about conditional statements? If we use them, we can kind of make a difference between different states, and then maybe inside those statements, we can actually depict a specific behavior. But at the same time, what if I told you that, okay, what if there are a lot of different states that we need to take into consideration? Well, then we need large conditional statements. So, in order to manage these different behaviors in a way that it is clean and there is some organization, state pattern would help instead of writing all those conditional statements, if, else, if, else, if, else. That would be so much better with state pattern. In a way, what happens is that the states are not conditions anymore; they are objects. They have their own classes. Now, if you have a class for each state, you can add classes slash states. You can modify classes slash states. Let's take a look at a very general UML. So what's happening is that we have the context class at the top, and then there will be a state interface, and then we'll have all those concrete states. Here, yes, there are three states, but it could be like any number. The concrete states kind of override the handle function in the state interface. In terms of relationships, there is a realization relationship between the interface and all those concrete states. It is not a new thing. We could see that in other patterns too. And also, of course, association between the context and the interface. Now, it's funny that to context class, a state is now a variable. What is it with the request? We will show you in code examples. Once we initialize some kind of an object in, let's say, the main program, straight out of the context class, then we can call all those methods of the context class. And that's kind of how we move forward with this pattern in terms of testing. Once again, let's quickly go over the components. Context class has that object that we're talking about, the object whose behavior changes based on whatever state you might give it. The state interface is just an interface, and later in the concrete states, we can kind of override, let's say, the functions in it. In concrete states, we are actually defining those behaviors for the states. Okay, now we're getting close to the more interesting parts. Before implementing this pattern in any kind of code, you might ask me, what is the common usage of this pattern? How can I actually benefit from this pattern? Why would I need to learn this pattern? Okay, so For the start, I could give you three words: finite state machines. To me, that's very general. That could encapsulate a lot of different aspects. I could actually divide that common usage into different other usages. Either way, imagine an object for me. This object can have a different state, but of course, a finite number of states. Once you have states, you have transitions between them. These transitions could be triggered by events. Now you might ask for an example. Okay, how about a game character? Imagine there is a character, a main character, let's say protagonist, and you're playing as that character in a game. Um, the character is fighting the enemies. Uh, Somewhere along the way, the character gets damaged. So the health goes, let's say, below 70%. It's kind of weird to see someone acting the same way as when the health or the energy is 100%. Something should change. Some behavior should change. The character should behave differently. If the character was standing still, now the character should be kind of tired. Not enough. I need more examples. Okay, let's together think and find something that would fit into a state pattern. What is a state pattern? Stage transition management. Where and when and how would we need to manage the transition between different stages? Okay, how about workflow systems like an order processing system? How about protocol handling? We want to manage protocol states. How about graphical user interface applications? The buttons, checkboxes, they might be enabled, disabled.